everyone. How are you guys doing today?
Good, how are you?
I'm doing fine, thank you. Okay. Hi Mia, hi Yusuf, hi Nitya, and everyone. Um, Wednesday, today is Wednesday. I feel like today is Monday. Hi Tahmina, Ryan, Laila, Lacey, and Tom. Hi Maria. How everyone is doing? All of you guys are. How you're doing today? I hope you guys are doing well. Hi, Wisan. Walaikum assalam wa rahmatullahi wa barakatuh, Jamina. Hi, Case. Is it Japanese or Chinese? The name you wrote. Japanese? Cool. I love watching Japanese animes. I love them a lot. But I find this language is, language itself is very cute, cool, but it's hard to read. Like you have characters instead of letters. So I gave up on learning. What animes do I like? I love anything in detective area. And I love funny stories, family stories, those things. That's why on my YouTube, I have few animes. I actually collected a lot, but YouTube blocked them all. And whatever remains, I have them in my channel available. But anyway, the main thing I love is the most favorable genre is detective. I love those a lot. So in one summer, I actually watched 1,000 Detective Conan's episodes. I finished 1,000 episodes in one summer. I was that crazy. And whenever I had time, I always just watch animes. It makes me relax. I love them. So I actually watch all sort of them. Chinese, Japanese. They have animes. And then I also watch Korean drama, Russian, Germany. I watch all sort of things. Good things, not bad things. Okay. Um Today I'm actually not feeling so good. I don't know why, but I'm feeling very down. So I don't have the energy today. I really wanted to cancel today's class, but I was like, well, maybe someday I'll really be more sick. And then I cannot take this class. So I'll leave my sick days for those. I am not feeling sick. I think I'm getting sick. Sometimes we know we are going to get sick, but we actually have nothing to do not to get sick. I hate this feeling. Thank you, Fatima. Uh, in fall, everyone gets sick. Yeah. I actually have a weird body. Every year I get sick, and it lasted for at least 1 week, 1 to 2 weeks, every year. So this year I did not get sick so far. That means it's coming soon, very soon. I'll get sick for a week. And then also I get cough every single year when the season changes. And doctor told me seasonal allergy. Last year or the year before, I don't remember. I actually had cough for 8 months. I went to so many doctors and they could not figure out what's wrong with me. So they did so many tests and everything. And then they realized finally that it's allergy plus acid reflux. Uh, so yeah, they also told me my throat, I stained my throat for coughing for 8 months. So I should not talk louder. I was like, my job is to talk louder. How can I not talk louder? Okay, Fatima, are you feeling better now? That's great. Thank you everyone um, for your what? Kindness. Okay, so does anybody have any question, comments, concern, anything before we start? Nothing? Okay, then. We are in chapter 6. And last class, we talked about disjoint events. And we said two events are disjoints if they don't have anything in common. Disjoint means they're not joint. They're disjoint. Disjoint has another word. We call them mutually exclusive. It means they have nothing in common. They're totally different things. So two events are disjoint if the probability of the intersection is 0. It means they have no intersection, no overlapping area. And for disjoint events, the addition rule, which we use for OR scenario, is the sum of the individual probabilities. But if you have two events that are not disjoint, then the probability the addition rule for their probability is we add the individual probabilities, but then we subtract whatever portion they have in common. So probability of A plus probability of B minus probability of A intersect B. Now, today we are going to learn independent events. Two events are independent if the occurrence of one event does not affect the chances of the occurrence of the other event. It means two events that are completely unrelated to one another. For example, flipping a coin and rolling a die at the same time. Well, when you flip a coin, it has nothing to do with rolling a die. They're completely different events. So we call them independent. Sometimes actually it's hard to figure out whether the events you're working with are independent or not. So that time we look at a different, we look at the events from a different angle. We say, well, the events A and B, they will be independent if the intersection probability of A and B is probability of A times the probability of B. Or the conditional probability, like probability of A given that B already happened is same as probability of A. It means we don't care about whether B happened or not. Probability of A is probability of A, regardless of whether we already have B happened or not happened. It doesn't matter. The difference between disjoint and independent is that we talk about disjoint. When you talk about disjoint, we look at the addition rule. Sorry. When we talk about the disjoint, we say that, well, the intersection of the two events, probability of the intersection of the two events is 0. So their addition rule is probability of A plus probability of B. On the other hand, when you talk about independency, we say, well, the intersection of the probability of the intersection of the two events is not zero. Instead, it's the product of the individual probabilities, means probability of A times the probability of B. So disjoint means, let me change the color. Disjoint means they're in, oops, I call it the, disjoint means their intersection is zero. Independent means the intersection is the product of the individual probabilities. That's how we figure out whether two events are disjoint or not, or independent or not. Now let's do an example. Suppose in a big restaurant, from 900 customers, 400 ordered chicken and 700 ordered beef. Also, 200 ordered both chicken and beef. Are the events ordered chicken and ordered beef mutually exclusive? It means, are they independent? Sorry, not independent. Man, what's wrong with me today? It means, are they disjoint? Mutually exclusive means disjoint. Ordering chicken and ordering beef, these two events, are they disjoint or there's something overlapping? What do you think? Any idea? Yes, Anton. Can you guys write on public chat box? Because if I open my chat box on the screen, I actually don't see my word, Microsoft Word. So I have to keep opening and closing my chat box. But if you write it on the everyone, I'm logged in from another computer, so I can see the comments there. Thank you, Anton. Yep, you're right. They are not disjoint. That's because look at here, 20, so yeah, 20, 200 people ordered both chicken and beef. Both chicken and beef means chicken intersects beef. For that probability, it's not zero, it's 200. But in order to be disjoint, our condition is that their intersection must be zero. So if you draw the Venn diagram, let's say this is chicken and this is beef. So we have 200 people who ordered both chicken and beef. And then 400 order only chicken. That means we have 200 here, because whole chicken from here to there is 400. And then 700 ordered beef. So if 700 ordered beef and 200 is in my together, so we have 500 here. So if you add all these numbers, we have 500 plus 200, 700, 800, 900. We have total 900 people here. And we also, they also observed 900 customers. Okay. I'm just giving you extra information. But Venn diagram is this: 200 on the left, 200 in the middle, and 500 on the right. Chicken and beef. Now they want you to answer whether these events, they're independent or not. So how do we check independency? What do you think? Are they independent or they're not independent? If you're not sure, you can ignore that for now. Let's look at the next one. It says, if you randomly ask a customer what he or she ordered, what is the probability that the customer orders chicken? In other words, what is the probability of chicken? So from the given information, what is the probability of chicken? Come on, guys. If you're not sure, ask me. But if you're sure, if you know the answer, please put it in the chat box. So Tal gave us one answer, 4/9. How did you figure that out, Tal? What did you do? How did you get 4/9? Excellent, both of you. See here, 400 people ordered chicken. We observed total 900 people. So among all these 900 people, 400 ordered chicken. So probability of chicken is 400 over 900. So when you cancel, it becomes 4/9. Perfect. What is the probability that they ordered both? So we are finding probability of both. In other words, probability of chicken and beef, or probability of chicken intersects beef. So this is the information we have. Based on the information we are given, what's the probability that the customer ordered both? Good job, Keys. It is 2/9 because observe 200 people ordered both chicken and beef. So out of 900 people, we have 200 of them ordered both. So we cancel this, we get 2/9. Do I have beef? No. Then let's do the beef here. What is the probability of beef? See the information. Probability of chicken is 400 over 900. Excellent job, Maria. Probability of beef, we observe how many people ordered beef. 700 ordered beef. So probability of beef is 700 over 900. So we cancel this, we get 7/9. Now we can answer B. Two events are independent if probability of C intersects B is probability of C times probability of B. Two events are independent if the intersection has the probability that probability of the intersection is the product of the individual probabilities. So from the right page, we found that probability of C is 4/9 and probability of beef is 7/9, which is 28/81. From the next question, probability of both, we found the answer is 2/9. So one side is 2/9, the other side is 28/81. Are the same? Of course not, right? So since independent, if this is true, but we found that this is not true. The left side does not give us the same number as the right side. So they are not independent. So to figure out whether they're disjoint or not, we did not have to do any math because the information is directly given to us. But to find independency, we always have to do math. We have to compare the left side and the right side of the equation. If we have the same number, they're independent. If we don't have the same number, they're not independent. Who has a question? Anybody? This is last year's final question, final exam. So you may see this type of question again in your final. The final will be made by the department. So if you don't understand it now, you should ask me now. Is anybody confused? Unclear about any of the concepts? No? We have more. What is the probability of why it's not independent? Okay. In order to be independent, we have one condition. The condition says probability of their intersection must be probability of the first event times the probability of the second event. So first event is ordering chicken, second event is ordering beef. So it says ordering chicken and ordering beef, are they independent? Well, they will be independent if probability of ordering both chicken and beef equals, so this portion is both. If probability of ordering both equals probability of chicken times probability of beef. So probability of both, it's how many people order both chicken and beef divided by the total number of people we have observed in the restaurant. So it's 2/9. Probability of chicken is how many people ordered chicken divided by the total number of people, which is 4/9. Probability of beef is how many people ordered beef from the 900 people. So it's 700/900, which is 7/9. So 4/9 times 7/9 is 28/81. But on the left side, we have probability of both is 2/9. So these two numbers, they are not same, they're not equal. Since they're not equal, that means they're not independent. So answering this question depends on answering this condition. So make sure you have this condition in your cheat sheet for the exam. Okay, how about the next question? What's the probability that someone ordered nothing? Neither chicken, not nothing actually. Maybe he ordered vegetables. What's the probability that the customer ordered neither chicken nor beef? How did you figure that out, Tao? Probability of no chicken, no beef. How did you figure that out? We have 900 people and wonderful. See, we can see all this explanation from the Venn diagram. Everybody ordered something. 200 people ordered both, 400 order chicken. That means another 200 order only chicken. 700 order beef. That means only beef. They ordered 500. So not only beef ordered 700, and then we have 400. Together we have 200. If you add all this information, we already have the 900 here. And he observed 900 people. So nobody is left to order nothing. Whoever we observed, everybody at least ordered something from chicken and beef. The answering this question is kind of depends on your observation. The Venn diagram. If you observe a Venn diagram, the sum of the Venn diagram is 900. That means it used all the information from the people you observed. 200, 200, 500. We have nobody left. Oh, one interesting question. Suppose you ask a customer who ordered chicken. So who already ordered chicken? Okay. Then what would be the probability that the same customer ordered both chicken and beef? How did you figure that out, Yusuf? 50%.
It's just so you take the total people of chicken, so the people who have like beef and chicken have chicken, obviously. So that's 400 total people who have chicken over the people who just had chicken. So it's 200 over 400. That's 50.
True. So we have chicken is 400. Now, sorry, it should be denominator. The total people who ordered chicken is 400. Now, in this 400, the people who ordered both is 200. So we get 1/2, which is 50%. Good observation. Who is lost? Who did not understand anything what you're doing here? These questions are fun only if you understand them. So if you're not having fun, that means you're not probably understanding them. So who is not having fun? Anybody? In last year's final, they had total 8 questions or 9 questions, around 8 or 9. Okay. In this 8 or 9 question, 4 of them are probabilities. So you can guess like how much they love probabilities, the department. So if you don't understand the probability, you should ask now. I'm here to help you. I cannot help you during your exam. So ask me everything you don't understand during class to help you prepare for the exam. So who has a question? Anybody? No. Okay. So okay. So since we are talking about independency, now we have 2 types of equation for independent events. If we are dealing with some events where we pick something and we replace the item right away, then we have one type of equation to find the probability. But if you pick something and don't replace and pick another thing, then we have another equation for their probabilities. So depending on what you're doing in your events. We have different, same question, same equation, but only the denominator is different. Okay. So for independent events, we do multiplication rule. In multiplication rule, we multiply the individual events if the events we are working with are independent. And if you are working with some events where you are replacing your items you're picking, then all the denominators stay same for every probability. But if you take something and don't put it back, you still use the same formula, but this time your denominator will be different for every probability. Let's do some example, things will be clearer. If you toss a coin and roll a die at the same time, what's the probability of landing a head of the coin and getting a 3 on the die? So we have two events. Tao already has an answer. Okay, we will see. It says 1/12. We'll check. So it says if you toss a coin, so you get two events. Our event 1 is getting a head. So probability of head is 1/2, and another event is getting a 3. So probability of 3, we are getting only 1 3 out of 6 choices. So we have 1/6. And these two events are independent because when you roll a die, it has nothing to do with flipping a coin. They're completely unrelated events. So you don't even have to check the condition. You can automatically see that they're unrelated. Now it says, what's the probability that getting a head and getting a 3? Every time you see the word and, it means multiplication rule. Since these two events are independent, so their probability will be probability of head times probability of getting a 3. Because they're independent. So we take their individual probabilities. Probability of head times probability of 3. Probability of head is 1/2, probability of 3 is 1/6, and our tau is correct. It is 1/12. You see? Cool. Since they're independent and actually this example is not related with replacement. With replacement, we are going to another example. This example is just example of two independent events. Now here comes an example where we actually do with replacement or without replacement scenario. Suppose we have a bin that has a 2 blue, 3 red, 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 and 4 green balls. Green, 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 green. Okay. Our bin has 2 blue, 3 red, 4 green balls. What's the probability of picking 1 blue ball? Any idea? Or take a minute, look at these examples, try doing them by yourself. Once you're done, put them in the chat box, and then we'll do them together. Just try your best. Yeah, going to get in the today. Today is 9/18. Usually I don't take attendance on Wednesdays, but no problem taking it today. Allison, are you there, Allison? Danielle, Elise. Okay,
Yeah.
Allison is here.
I'm here.
Elise, here. Okay. Yasmin, are you still there?
Yes, I'm still here.
Okay. Ryan, are you still there? Ryan, Jenny. Thank you. Anton, are you still there? Okay. Christina. Thank you. Birimichi. Okay. Christopher. Christopher, finally you are here. Miyako. Noor. Noor. Na. Ramis. Okay. Jamina, are you still there?
Professor, you said Tamina or Jamina?
Jamina. Here. Okay, Jamina here, Tahmina here. Both of you are here. Waiting. Waiting, not here. Hyun. Here. How is here? Lila, are you still there? Perfect. Jason, Luke. Here. Yusuf, are you still there? Perfect. Christabella. No. Nithya, are you still there? Nithya. Kevin. Here. Salma. Here. Keith, are you still there? Perfect. Karina. Here. Maria, are you still there? Perfect. Mia, are you still there? Wonderful. Wendy. Here. Sebastian. Fatima. Great. Abhinav. Not here. Queenie. Great. And finally, Jason, Jew. Not here. That's why I don't like taking attendance online, because I can see their names, but they're not present. Okay, are you guys able to figure this out? Who would like to answer A? Okay, Dirimichi is number of colored balls, number of perfect Dirimichi. The way we find the probability is how many we have from the color they're asking us divided by the total number of balls. So total number of balls we have total is 9. So 4, 5, 6, 7, 8, 9. So all of them, they will have denominator 9. Since this one is asking for blue, we have 2 blue. Probability of red, 3, 9. Wonderful. Which is 1/3. And probability of green, we have 4 greens. Great. So now you guys understand how to find this probability. Next one is an interesting question. It says, suppose you pick a ball, put it back, and pick another ball. Now, what is the probability that first you picked a red ball and then you picked another red ball? So see, you picked it up and put it back. When you put it back, your total number of balls are not changing at all. So probability of picking the first ball red is the original one, 2/9. And means multiplication. Now, since you took a red ball but put it back, that means we did not change anything at all. So probability of picking another red ball is same as picking the first red ball. It's the same thing, 2/9. It's only because we did not keep our ball. We put our ball back and we are picking the next one. Red? Thank you. My bad. So 3 out of 9, 3 out of 9 is 1/3 times 1/3, which is 1/9. Thank you for catching that, Tao. Okay, anybody has any question? Then try the next one. What's the probability of first ball is blue, second ball is green? And then let's say now you're doing it 3 times. Then what's the probability? First one is blue, second one is red, and third one is green. Any idea? Or do you want to see number of balls? So these are the number of balls we have. 2 blue, 3 red, 4 green. So 2 blue, 3 red, 4 green. What's the probability the first one is blue, but second one is green? Anybody? Come on, guys. If you did not understand, ask me a question. Yes, the same thing. You're picking a ball, putting it back. All these questions are under the same scenario. Okay. How did you get 8/9, Maria? What did you do?
So I multiplied 2/9 and then 4/9.
So 8/what?
9.
Really?
Sorry.
When you multiply You multiply top, bottom, bottom.
81.
81. Tau. Why? Oh, you got F. Oh. So F tau says 8/243. Okay, you will see. It's okay. You did it in advance. So what did you do for F? How do you get 8/243? So we have blue is 2. We have red is 3. And we have green is 4. So the total, we can reduce this to 1/3. So we have 9 times 9, 81. Times 3 is 243, correct? And we have 2 times 1 times 4, 8. Great. You got it correct. Wonderful. Is there anybody who is confused? Any question from anyone? So remember, we are putting our ball back. When you put the ball back, that means the number of balls is never changing. That's why all the denominators, they never changing. But this will not be the case if you don't put your balls back. So when you do something without replacing, then we still have the same formula, but this time, every event we are doing after the previous one, our denominator will be reduced by 1. Could you explain F? No problem. Let me erase. So F says, this time you are picking 3 balls. What's the probability that the first ball you are picking is blue and second ball you are picking is red and the third ball you are picking is green? So it's probability of blue times probability of red times probability of green. Since each time you are picking a ball and putting it back, so all the denominators, they are same. So how many blue we have? 2. How many red we have? 3. How many green we have? 4. When you multiply all of them, they will be 8/243. No problem. So when you replace a denominator, never changes. It's same for every event. But when you don't replace, a denominator gets reduced by 1 for every event after the previous one. What do I mean? Look at the same example. We have 2 blue, 3 red, 4 green. But this time, you're picking a ball and don't replacing it back. So once you pick the ball, you're keeping the ball. That means from the bin, you're losing 1 ball. So if this happens, what's the probability that you're picking 2 balls and from there, your first ball is red and your second ball is green? So probability of first ball is red times second ball is green. So we have blue, blue, red, 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 green, 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 green. So For the red, we have 9 balls in our bin. So denominator is 9, and we have 3 reds. So we have 3 choices out of 9. Now, from the 3 balls, you picked one and you did not replace it back. You put it in a pocket. That means to pick the green ball, how many total balls do you have in your bin? Do you still have your 9 balls? No, right? You put 1 ball in your pocket. That means you left with only 8 balls in the bin. So in these 8 balls, how many greens you have? 1, 2, 3, 4. So it's 4 out of 8. You see the difference? The denominators are getting reduced by 1. So each time you pick something, you keep it, you're losing 1 ball from your bin. As a result, the next event doesn't have the total ball as the previous one. It has 1 unit less than the amount of ball in the previous event. Okay, I actually had one more question, but somehow it got deleted. The next one is, what's the probability that red, green, and green? What's the probability that the first ball is red, second ball is green, and also third ball is green? Now this time you're picking 3 balls, one at a time. You're taking 1 ball and then you're keeping it. And then you're taking the second ball and you're keeping it. And then you're picking the third ball and you're keeping it. So if you keep doing that, what is the probability that the first ball is red, second ball is green, and also third ball is green? What do you think? Any idea? Tell me what's wrong today with you guys. Are you guys not understanding the materials? Or you guys are just lazy, not giving me the answer? Which one? Thank you, Christina. Trinity. So you have 3/9 times 4/8 times Christina. It should be actually 3/7. And it's 3 because when you pick the first ball, green, you're losing 1 of the green balls from the 4 balls. So that means in your next choice, you're left with 3 green balls. For example, here, blue, blue, red, 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 green, 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 green. Probability of picking red, we had 3 of them. So it's 3 out of total 9 balls. But once you pick 1 of them, you lost your red balls. That means for the next one, you had total 8 balls left. In these 8 balls, you have 4 green choices. So it's 4 green balls. But once you pick 1 of the green balls, see, you don't have any more 4 green balls. You have 3 green balls left. And you have 3 green balls left. And now this time you have total only 7 balls left. So it's 7. So it's probability of red times the probability of green times the probability of green. No, you're not picking at the same time. Even if you do pick at the same time, same scenario, you think of it as you're picking one after another. Because the scenario says you're picking one ball, not two balls at the same time. Okay, so you're picking three balls, but one after another. Even if you don't take one after another, it doesn't matter. The rule applies for everything. So when you pick three balls, think of it as you're picking one at a time. That means you want to take first a red ball. So we have total 3 red, 4 green, right? This is our initial setting. We have 3 reds. So in our bin, we have total 9 balls. In these 9 balls, we have 3 greens. Sorry, 3 red. So we have 3 out of 9 red balls. Now, once you pick one of the red balls, because you picked your first ball, and that was red ball, you kept it in your pocket, and now you're picking another ball. Now, when you're picking the next ball, you want to get a green ball. So what's the probability that this time you're going to get a green ball? So we have total 4 green balls. So we have 4 choices. But look, this time, after you keeping your red balls, how many balls you have in your bin? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 now. So it's 4 out of 8. So the second ball was green. You keep it in your pocket. And now you're going to pick another one. And this time you want also another green ball. So we have total 3. Oh man. We have total 3 green this time. So it's 3. But observe our denominator. 1, 2, 3, 4, 5, 6, 7. We have total 7 ball. So it's 3 out of 7. If you pick 2 green balls at the same time, it will be 3 out of 9 and 3 out of 7. No, 3 out of 9 and 2 out of 8. Because one of the green will reduce on the numerator and the total number will reduce on the denominator also. So you're reduced by 1. So we have green, 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 green. If you take 2, you think of it as you're picking one first and then the second one. So picking the first one is 4 out of 9. And then picking the second one, it's 3 out of 8. If you're only talking about green balls, not red, not anything else, only the green balls, then this is the scenario. Is it clear, Dirimichi?
So does the denominator go lower depending on the probability then?
Yeah, for every event, our denominator get reduced by 1 unit. So here we have 3 events. Probability of picking red is our event 1. Probability of picking green is our event 2. Probability of picking another green is our event 3. Since we are picking 3 balls, so after every event, we are losing 1 unit from our total number. So for the first event, we have total 9 balls, our denominator is 9. Once we take one of them, that means we left with 8 of them in the bin. So it's 8 this time on the denominator. So we took 2 of them out. That means we left with only 7 of them for the third event. So every event get 1 unit less denominator than the previous event. Clear? Okay. Same thing, but a little bit different. We have 2 blue, 4 green. No more red this time. So we have 2 blue, 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 and 1, 2, 3, 4 green. If you randomly select 2 balls from the bin, find the probabilities. Well, they did not mention why they are picking the balls at the same time or picking them one after another. Even though they did not mention, well, it doesn't matter. We can apply the same rule for any scenario. So here it says, if you take 2 balls, what is the probability that the 2 balls you are picking are 2 blue balls? Again, even though they did not mention you're picking one after another, but you can assume, you can apply the same rule for picking one after another without replacement. Are you guys confused? So we have 2 blue balls, right? And we want to take both of them. We can divide this even into 2 pieces. Let's say we are picking 1 blue first, and then we are picking another blue. You can take them together, or you can take them one after another. It doesn't matter. You can divide your events. You can divide your one event into 2 events. So if you divide into 2 events, probability of picking the first blue ball is 2 out of 6. Perfect. But since you took one of them and you are not putting it back, so you're left with 1 choice and then 5 total ball. So it's 1/5. So it took 1, there's no more blue, and then it took another one, so no more blue. It's 2 and then 1. 1/3 times 1/5. Let me see. Oh, let me actually do it again. Blue, blue, green, 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 green. Probably to 2 green, you can assume the same way. You want to take the first green, so we have 4 out of 6. But once you took it out, no more green left. That means for your next green, you have 3 choices, and your total 5. Yep. 4/6 times 3/5, which will be 2/5. Okay. Something very interesting. What's the probability that the two balls you're picking, they're the same color? And then what's the probability that they're different colors? So what do you think? They did not mention which color. Is it blue or is it green? They did not mention that. They simply said same color. Any idea from anyone? How did you get 115 and 2/5? What did you do? Tell. Probability of getting 2 blue balls was 1/15, true. And probability of getting 2 green balls was 2/5. Oh, okay, I see. The idea is okay. There's only one mistake. You didn't multiply, you add them. Why? Because of this. Same color. Which color is it? Is it blue or is it green? We don't know. So it's probability of 2 blue or probability of 2 green. Could be the 2 balls you're picking, they are 2 blue, or the 2 balls you're picking, they could be 2 green. See, because it's or, that means it's plus. And probability of 2 blue, we already did it here. So it's 2/6 times 1/5. Probability of green was 4/6 times 3/5. So it's 1/15 plus 2/5. You can keep it, you can keep this. Instead of seeing the final result, I actually like to see this result. I want to see you understood the concept. How'd you get 15? Okay. Here, when you reduce 2 goes to 6 3 times. So you have 1/3 times 1/5, which gives us 1/15. Multiplication is for and. Anytime you are using the word and means multiply. Anytime you are using the word or means add. So picking 2 blue balls, it means the first ball is blue, first blue, and second blue. See, I said and, that's why it's multiplication. But when you're working with same color, it means we have 2 blue ball or 2 green ball. Okay, Mia, no problem. Okay, now it says that 2 balls you're picking, they have different color. You have 3 ways of doing it. One of them is probability of same means 1 minus probability of different. Sorry, the other way around. Probability of different is 1 minus probability of same. And we already found the probability of same here. So it's simply 1 minus 1/15 plus 2/5. That's method 1. Method 2 is like how we did the first one. I mean, how we did the C. It is different color. It means maybe the first ball we are picking could be blue and the second ball we are picking is green, or probability that the first ball we picked is green and the second ball we picked is blue. So one of them is blue and other one of them is green. So the order doesn't matter. I mean, order does matter. So maybe we are picking the first one first, or green one second, or the green one first and blue one the second. So in any order you pick, we have two choices. Since it's OR, so we are going to add the two results. Now, probability of picking blue and green. If you pick blue first, blue has 2 of them out of 6. Once you picked one of the blue, that means you left with 1 less than 6 ball. So for green, we have 4 of them. Or if you pick green first, we have 4 greens out of 6. And once you pick the green one, now we have 5 left in the bin. In these 5 balls, we have 2 blue. So we have the same thing twice. So either you write this way, or the third choice is 2 times 2/6 times 4/5. Okay. Because you have the same thing twice. So you can simply do it once and multiply by 2. The result will be the same. So 3 ways you can answer D. And with this, we are done with today's lecture. 8/15. Okay. The answer is 8/15. Well, actually, do you have the answer? 8/. It should be 15, not 5. Thank you, Fatima. So, again, this was a finalism question. So there's a high probability that you may see all of this again in your final. I do not make the final, so I have no idea what will be in the final. You have to practice a lot to get prepared for the final. Plus, in the exam, I'm definitely going to ask you one of these. Okay? Especially this type of question. Having the same color, having the different color, with replacement, without replacement, what is happening? So, even if you did not understand now, make sure you read the book or watch others' recordings, other videos to understand them. And if you still do not understand anything, feel free to ask me on Monday. Nope. But I'm going to post the recording. So since I already have all the slides up on Blackboard, you can simply write the answer down on those. Okay. Thank you everyone for your participation. Thank you for being here. Have a good day, have a good night, and also have a good weekend. Thank you, Christopher. Thank you, everyone. Thank you, Wendy. Thank you, Doramichi. Thank you, Lacey. See you all guys on Monday.